Now, once you have an SCE, how do you know that your SCE is functional? How do you know your SCE will be able to mitigate or will be able to relieve you of the consequence? Or if the consequence actually happen, how do you ensure that your SCE is there to reduce the severity of the consequence? So the industry came up with what we call FASI. Everybody has a definite, they have whatever they call it. I call it a FASI. So if you look at a FASI define the performance standard of your SCE. If you develop an SCE or you identify an SCE, you have to make sure that anything anything that has been categorized as an SCE has to be functional. Functionality means is that it is designed to function to relieve you of that consequence. It is designed either to prevent or it is designed to mitigate. The next thing you want to do is that you want to find out that is your SCE available? And that's why if you look at SIS or Safety Instrumented Function or SIS, they do a proof test to be able to check whether it can perform when demand is placed on it. Is it available when you need it? Is the PSV available when you need it? Reliable. Will it take me to a safe place? Survivability. Will it survive if there's a fire? Will it survive if there's a failure of another independent protective function? And that's why fireproofing requirement is a big one when it comes to the oil and gas industry. And that's why to HAZOP is good, but quantitative risk assessment can actually complement your HAZOP. Because if you do your HAZOP, you know your qualitative risk. If you do a QRA, you can know the severity of the consequence. Now, the last one is where a lot of people make a lot of mistakes. Do you know if you create or you identify or you design a safety critical element, do you know whether it is depending on other elements to function? Do you know whether it interacts or do you know the dependencies? And that's why some people will say, oh, I have a fire failure in my plant. My DCS did not function. My SIS did not function. A lot of things did not function. It is because they've not been able to look at the interrelationship or the dependencies between all these that are designated safety critical. Now, you will challenge me at the end of the day to say, okay, why am I talking about safety critical equipment? The failure of safety critical equipment has led to some of the most disastrous or catastrophic incidents in the history of the world. You know, one that comes to mind is the failure of the LPG in 1984 in Mexico. Again, this is basically because there was a failure of an SCE. The painful thing is that this happened really on a day where people didn't expect it to happen, in the early hour of the morning. The severity of the consequence was that they had 600 fatalities, 700 injuries, and 200 people were evacuated. I want to give credit to CCPS for always showcasing this. And if you want to find out more about this event, in the interest of time, you can go to the CCPS November 2014 edition, and it will tell you what you can do to ensure that this does not happen. Again, what happened on that day? They have a failure of the LPG system. The LPG system could have stayed intact if there was a quantitative risk assessment done. There was no passive fire protection system on the plant. There was ineffective gas detection, inadequate spacing of the tank, and improper maintenance of safety equipment. The beauty is you can design it right, you can construct it right, you can operate it right. If you don't maintain it right, you do not have a safety critical equipment. Designing is one thing, operating is another thing, but if you do not maintain it, it will not work. And that was what led to 600 fatalities. And that's how reactive our industry is. The next case study, this happened in 1999. It was because of a partial power outage. This led to a release of hot caustic liquid. And this permanently injured 29 people, $10 million. Fortunately, there was no fatal injury. Again, what is the cost of this? Yeah, the event will always happen, but you paid a lot of money. You spent a lot of money to actually design your barriers or your safety critical equipment or your safety critical safeguard or barriers, and that fails. Again, pressure control system failed, high pressure failed, pressure reliever was disabled by the operator or the maintenance people because they didn't know what was happening. The last case, I have two more case study, then I can take question if you have question. This one was also, again, overfilling of the tank. Bunksfield disaster. Everybody knows Bunksfield disaster, the one that happened in England in 2005. This led to 43 people dying. 2,000 people were evacuated. Fortunately, there was no fatality. But you know the sad part about Bunksfield? After Bunksfield happened in 2005, the Texas refinery had similar incident caused by the failure of a high-level shutdown, independent shutdown function. It was designed but couldn't function on that day because maintenance was not properly done. Fast forward 5 years later, in 2010, Caribbean Petroleum Company, CAPECO, had the same similar incident, which talks about the reactiveness of our engineering world or the safety world. The last one I want to talk about, this one beats my heart, and this one is a really, really sad event, and that's why I want to showcase it. This happened in October 2019, not too long ago. This happened in Texas. A lone worker, a maintenance worker, was reacting to a plant, and when he got there, again, in the works of life, you get too busy, he forgot to do lockout tagger. That was actually not the most important thing. What failed that day was that the H2S alarm was disabled. It didn't ring to the operator when there was a release of H2S as a failure as a result of the pump automatically starting, which was caused by the maintenance guy itself because he didn't do lockout tag out. And the painful thing was that when all the barriers that were called safety critical failed, the wife didn't see the operator, the maintenance guy, and the wife went to the plant to go look for him. And when the wife got there, she also fatally died because she was exposed to H2S. Guys, SCEs can be designed well, but if it is not maintained well, or if people don't know what is the function of an SCE, it becomes a problem. So what can you do differently? Again, I've talked about the inspect, you test, you do the preventative maintenance, which is the stage 4 of my presentation here. If you can design it right, if you can operate it right, you must maintain it right. And you must have the right people. And you must have what we call a standard, a performance standard, working with subject matter experts, barrier owners, relevant stakeholders to check the functionality and to test and to maintain those SCE to make sure they work when you. Well, when it comes to safety critical equipment, there are a load of materials out there. There are textbooks, there are standard. You can, I think CCPS has published something on safety critical element or equipment for common language of consistency. The UK HSC is big on it. I believe that may be one of the reasons why Achuro has the HSC UK has loads of materials, because that's after the incident they have in a Fleeceboro disaster. That's after the incident they have. The HSC case is big because of the control of major accident hazard. So I would advise people to also visit the UK HSC website. And if you want to connect with us as Riskless, we can also provide you material on HSC case, materials on safety critical equipment. And we're also happy to do a launch and learn for organizations who are looking to be safe, because our own complaint, our role is to make the world safer. Whether you are our client or not our client, we just want to make sure that everybody goes home safe.